David Smith here with another flipped classroom math video. A few tips before we start. Remember that you can speed up or slow down the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or to try the problems before I explain. Lastly, you could turn on the captions and follow along with my words on the bottom of your screen. Today's topic, probability with independent, we're saying compound events. So a compound event is like an event that's comprised of two things. These are independent compound events. So you could have a three-thing compound event as well. We're going to stick with two right now. So this is the occurrence of one event that does not affect the occurrence of a second event. So here's an example. I have a spinner here with three colors. Those are equally likely three colors. And I have a coin flip with heads or tails. Okay? So you can pretty clearly see that no matter what I get on the spinner, it's not going to change what I could get with the coin flip. So these are truly independent events. So let's take a look at a probability question. What's the probability of getting red and tails? So we have three ways to analyze this. I'm going to go over all three. Our first one was through making a list. So we have red heads, red tails. Then we have blue heads, blue tails. Then we have yellow heads and yellow tails. So there's 6 possibilities. That's what we could get with this compound event. And we wanted red and tails, so that's right here. So we have 6 total, so that's 1/6, which is like approximately 17%. Let's do it with a grid. So heads, tails, red, blue, yellow, and a dot for each possible outcome. So that's the spinner, that's the coin flip. We have 6 possible outcomes. And what's our what we're looking for? It's red and tails. So red and tails is right there. So again, that's 1 out of 6. Okay, trees I think are the more complicated of the two, and there's 2 ways to do this tree. If you do it correct, it doesn't matter which way you go. I'm going to do my spinner first. So 3 ways to spin. That's red, blue, and yellow. Okay, and then 2 ways to flip your coin. Heads or tails, heads or tails, and finally heads or tails. So what's our outcome that we're after? Red tails. So that's this one. And we can see that at the end of our branches, there's 6 ways we could wind up. So again, the probability is 1/6. Okay, I'd like to give you one of these to try. So feel free to pause the video once I explain the problem and see how far you can get. What I'm looking for is a list, a grid, and a probability tree. So I think it would be a good idea to spend some time with that. Remember, you can pause the video anywhere along the way and kind of leave the lifting for yourself and then check once I explain. All right, so let's get started. 2 things. You've got a bag that has marbles, 1 each, brown, yellow, and green. So there's a bag that you reach into, 3 marbles in there, and you can pull out at random a brown one, an orange one, or a green one. So whichever color you pick, it's equally likely that you'd get that color. Second thing is, we have a spinner with 5 equally likely numbers on it. Pretty simple, it's just 1, 2, 3, 4, 5. So you spin that spinner, and it's equally likely that it's going to land on any one of these numbers. So go ahead and make a list of all the possible outcomes. Okay, let's see how you did with that. 1 each. So we're going to go through this. We're going to go brown 1, brown 2, brown 3. All the way to brown 5, and then I'm going to do the other colors. So brown 4, brown 5. Then I've got orange 1, orange 2, orange 3, orange 4, orange 5. And then finally we're going to do, what's our last? Green. So green 1, green 2, green 3, green 4, green 5. So how many outcomes is that? 15. So let's just write that down over here so we can keep track. Okay, so there's our list. Now make a grid. Okay, let's see how you did. This is going to be a 3 by 5 grid. So I'm going to go brown, orange, green, and 1, 2, 3, 4, 5. And then I get a dot for each one. And I can count up my dots, and I got another 15 for that. So I'm going to squeeze my tree in down there. It's probably going to get a little messy. Just bear with me. So 3 colors, 5 numbers. I'm going to do my numbers first. My colors first. So this is orange, brown, and green. And then I'm going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So, not my best tree, but it's all there, and that would be fine if you gave me that on a test or a quiz. Okay, now that we've got our 3 systems for calculating probabilities, I've put up 4 probability questions for you to consider. If you'd like, you can pause the video and see if you can work out those probabilities, then start it up again and see how you did. But before you do that, let me explain. This one is the probability of orange and 3. This is the probability of a brown and even. This is the probability of not having a green. This is the probability of not having an orange and not having even. So go ahead and see how you do. Okay, let's attack these. Probability of orange and 3. There's only one of those. That's this one here, orange 3. I'll circle that. There's only 1 out of 15 that does that. So this is just 1 over 15. Pretty straightforward. Now let's get a little bit more complicated. Brown and even. I'm going to use my grid to take a look at that. That would be brown and even. That's this one and that one. Those are the 2 brown and even. So this is 2 over 15. Not green. So technically, we don't care about the spinner on this one, right? We don't care. It just has to not come up green. So what's that going to be? I really only have 3 colors, so that's going to be 2/3. Okay, so that was a little bit more simple. This one actually doesn't care about the spinner. Now this last one is perhaps the most complicated one. Not orange and not even. So I'm going to go take a look at my tree for that one. Not orange. So this branch doesn't matter. Everything that goes off the orange branch has an orange, does not satisfy our not orange. So we can now analyze the brown and green branches and see what we've got. So we just want not even on the brown and green. So not even is odd, so that would be this one, and this one, plus that one, and that one. So that's 6 outcomes out of our 15, so that would be 6 over 15. Okay, I'd like to take a closer look at that example because we're going to bring out a rule that we can use to calculate probabilities. So here's our situation. I blew it up so we can talk about it more in depth. We have a bag of marbles with 1 each of an orange, brown, or green marble in the bag. And then we have a spinner that has 1 through 5. All the outcomes are equally likely. So there's an even chance of picking each marble. And then 1, 2, 3, 4, 5 on the spinner all have equal chances of coming up. Okay, so let's take a look at some of these things individually, like looking at the marbles. What's the probability of getting a green marble? 1 out of 3. There's 3 in the bag and 1 of them's green. So 1 out of 3. How about the probability of spinning even? So if we look at a spinner, 2 and 4 are even, the rest are odd. So probability of even is 2 out of 5. Now we can take a look at the probability of getting both of these things, and we'll use our tree to do that. So the probability of green and even. So green is here, and then even is here. So it's this branch with green, and then the 2 even options. So we have 2 out of, how many branches do we have total at the end? We have 15. So for our compound event, that is pulling a marble, spinning a spinner, there are 15 possible outcomes if we count those 2 things together. So we learned that this is 2 out of 15. Okay, now I want you to pause the video and think real hard. There's something that is interesting about these two numbers and winding up with that one for the probability of both. So see if you can figure out a mathematical relationship. Okay, so if you noticed that multiplying the probability of the first one by the second one gives us the solution, you got it. Because 1/3 times 2 over 5 gives us 2 over 15. Okay? So that's interesting. In fact, we're going to exploit that and make a rule out of it. So here's the spot for the rule. If events A and B are independent, then the probability of A and B, that is, both of these things happening, in our case it was the marble we wanted and the spinner result we wanted. So if the probability of A and B is going to be the same as the probability of A times the probability of B. And we're going to use this rule a lot. Okay, so let's do some calculations using that rule we just developed. So I've got 4 problems here. If you want to pause the video now and see what you get, go for that. Otherwise, pause it after each explanation. Okay, so probability of getting a tail and rolling a 2. These 3 situations are toss a coin, heads or tails, roll a die, 1 through 6 could come up. So probability of a tail and a 2, tail is 1/2, because there's 2 outcomes with a coin, heads or tails, and a 2 would be 1 out of 6, because there's 6 sides and a 2 is just one of those. So the probability of a tail and a 2 is 1/12. Okay? So around 8%. How about head and odd? See if you can do that one. Okay? Just like a tail, head is also 1/2. Now odd on the die is 3 out of 6. There are 3 odd numbers on the 6 sides, and we get 3 out of 12, which we then can reduce to 1/4. Okay? So there you go with that one. Give this a try. A tail and not a 4. Okay, tail again, 1/2. Not 4 means the other 5 numbers. So there's 5 out of 6 on that. So this would be 5 out of 12. Okay? So those are 3 pretty straightforward ones. And we're going to combine this math with our trees a little bit later, and it's going to make the trees are going to be super helpful with probability. Okay, try this last one. We have a coin toss, we're going to roll a die, and we're going to pull a card from a standard 52 card deck. If you don't know what's in that deck, you probably want to take a look, do some research, and figure out how a deck of cards is organized. So see if you can get that one. Okay, so a head is 1/2. A 6 is 1/6, because there's only 1 6 on the 6 sides. And a heart. Now a deck of cards has 4 suits. They're evenly divided, so there's 13 in each of 52, or in the 52 card deck. So I can put 13 over 52 there, and I can multiply out. But 13 over 52 is 1/4. So that's going to be a whole lot easier. So I'm just going to reduce that before I do my multiplying. 1/4. The other way to think about that is that if the deck is evenly divided into 4 suits, then the odds of getting any one suit is 1/4. So we multiply this out. 1 times 1 times 1, it's still 1 on the top. 2 times 6 is 12, times 4 is 48. So it's a 1 in 48 chance of flipping a coin and getting a head, rolling a die and getting a 6, and pulling a deck pulling a card from a deck and getting a heart. Now that you've finished, write down any questions so you can bring them to our next class and get some help. Remember that you can always watch the video again to improve your understanding. If you enjoyed it, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.